Good morning, GIS 300. Today we're going to use ArcGIS Pro to explore some census data using dot density maps to show population and then find the center of gravity of that population as a point. Open up ArcGIS Pro. You can go through the Start menu down here, ArcGIS Pro. Click on that and you will land here. Click on New Blank Templates, Map, and we'll call this Rustic Census. Okay. And do make sure that goes to your G Drive or your Google Drive file stream. If you're working on one of the lab computers, and if you save this to the C drive, it will not be there when you come back. Always, 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 always save in the Google Drive file stream if you're working on our lab computers. In the Brightspace folder, you will find this blocks 10 zipped compressed folder, which when extracted will give you these shapefile files. Remember that a shapefile is made up of many files, usually at least 4 or 5, but in this case we have 1, 2, 3, 4, 5, 6, 7. If you wanted to move this shapefile from one place to another or send it to somebody else, you would have to take all of these and either attach them to the email, which is not preferred, or select them all. I'm holding down the Shift key to select all. Right click, send to compressed folder. That creates this. This can be attached as a single file, which your recipient can then download and extract, getting these files back at the other end. So take the blocks10.shp file type, which is 9,000 kilobytes. Click, hold, drag, release, place above the topographic base layer, and that is the block level census data for 2010. Now let's create a dot density map where the number of dots within each block represents the number of people in such a way that maybe 1 dot equals 10 people or 1 dot equals 100 people. It gives a very good visual depiction of population or other quantities. Right click, Symbology. Under the primary symbology drop down, click once down to dot density. First thing you have to change is the field that it's reading from. This is reading the object identification number, which of course is nonsense. So, under this drop down, POP10, population in 2010. Click once, and there we go. If the sidebar goes away like that just did, right over here, symbology brings you right back to where you were. Now it's important to know that these dots are randomly placed within these census blocks. It doesn't mean somebody lives here or that 20 people live here. This is the North Branch of the Birch River, and this is, that's actually the Dickwood Lake Wildlife Management Area, and there are no permanent residents there. So it's important to recognize these boundaries exist. But once you recognize that and understand these dots are randomly placed within here, visualizing the data without precisely locating it, then we can go into symbology and change this background. And let's go ahead and go to the properties of that. Change the outline color to no color. See, that went away. I have to go back into symbology. No color, apply, boundaries go away, and the dots stay. Now I can right click and zoom to layer. Now that gives me a much better visualization of those data, still understanding that they live within those original polygons. And we can see very clearly a lot of the settlement patterns of Aroostook County. We have the St. John River in the St. John Valley and the Fish River chain of lakes. And we have the farmland of Caribou, Presque Isle, and Holton. Now let's do the very common task of selecting some data that we're particularly interested in our case, the St. John Valley. Under the Map tab, select. Drop down, select by lasso. Click and hold to start, drag to continue, still holding down the mouse key. And I'm going to call it right there, right, wrong, or indifferent. Avoid those areas. We're going to avoid Portage Lake down there, just because. And those are now the census blocks that we're interested in. Right click, Data, Export Features. That opens up this sidebar. Might take a minute. And that sidebar one wants to go away. And let's see, we're under geoprocessing here, so geoprocessing to get that back. And now, see, as I hover over that, I have the option to drag that out and have that bigger. All I need to do is look for this asterisk. It needs information there, and that information is just going to be a name. So I'm going to call that St. John Valley Census, and run. Just a moment later, we have the exported feature here. And now I'm going to go ahead and clear this selection, meaning deselect the currently selected features, and then I can uncheck my old blocks 10, and now right-click Symbology, and in the same way turn this into a dot density map. So that needs to be dot density type, and the field needs to be pop10. This background color I want to be no color. Apply, back, and there we are. And I can change things here. 1 dot represents 40 people right now. I can change that to 10 if I like that, and see how that populates much more. I can see more of those points. I can change the color ramp here. Let's try shades of gray. We can go with shades of blue. We can go with reds. This is a little bit clunky, so you see it isn't really giving me a choice to pick a single color that I want. I'm sort of clicking on ones and it's picking somewhere from this color ramp. I can also go under More, Format All Symbols, Color, Black, Apply, good, back, done. So you can go ahead and ignore this drop down and just go straight to More here. With all that done, right click, zoom to layer. Now we're looking at the St. John Valley, and 1 dot represents 10 people, but do remember these dots are not precisely located, they are randomly placed within a census block. Now the question is, where is the center point of this population? If all of these weighed a certain amount, where would this feature balance? And one of the values of a dot density map is it allows you to sort of visualize that kind of thing. And I'm going to guess it's going to be right off the tip of Long Lake here, where there are some people, but it's not really where a whole lot of people live. It's a geographic thing. It's not really a who can drive there the fastest. It's just ignoring all roads and all other features on a flat map. Where is the center point? I'm guessing here. You go ahead and guess somewhere else, or if you think I'm right, cool. But go ahead and predict where you think the center is going to be. Now that I've said that, I'm second guessing myself and maybe adjusting my estimate to here. So here, you go ahead and pick where you think it's going to be. Now, the first tool is called Mean Center, which you can find under Analysis tab, Tools. Over here that opens up the Geoprocessing tab, and I'm going to search Mean Center. And there you go. Click on Mean Center. Input feature class is St. John Valley Census. Output feature class, mean, so it wants that file path to live there. That's okay. I'm going all the way to the end here. And I'm going to accept that default, actually. St. John Valley Census, Mean Center. Thank you very much. Weight field. That has to be population 10, so it's weighting each one of these areas by the population that lives within them. And we don't need either of these, so we just need to have population 10 here, a place for it to land, and point it at the right data set, and run. Run, 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 run. And there it is. I was pretty close. So the mean center. That is defined as the geographic center of all of this population. The other tool is the median center, and the median center minimizes the straight line distance from all points to the center point. It is better to represent the outliers, and we have outliers here out in the town of Allagash. Also, St. Paul Lake and Van Buren has some outlying populations here. So if we're trying to be fair to this entire population, minimizing the distance to them, even if these points have an overwhelming influence on an average, these still count. So, under geoprocessing, which now lives here because we've used it before, go back from mean center and find median center. Spatial statistics tool, click, same as before. Input feature class is St. John Valley Census. Output feature class defaults to St. John Valley Census median center, very good. Weight field has got to be pop 10 as before. Leave the rest alone and run. And that didn't take much time the last time, so there we go. And that, curiously, the major influence has been to move it a little closer to the border and Route 1 here. That's not because it's attracted to those things, but because the sort of balancing influence of all of this has had that effect. So that's interesting. Is that a meaningful difference? Could be, could not be, depending on your perspective. But for every individual within this data set, every single member of that population 10 category, this has sought to minimize the straight line distance, where this is just the geographic mean of that population. And you see, in this situation, very little difference. This isn't a great data set to illustrate the differences between them. But for practical purposes, it's not a bad thing that both of these have fallen in the same general area. We don't have to debate the merits of one versus the other. If we're going to build something here, well, just pick some practical place that happens to be in this general vicinity. But then there's the issue of how long does it take to actually get there? Nobody can just, well, some people can just fly here, but most of us cannot just fly here, so we have to take a road, and the road is going to be different from the straight line distance. So the major access is going to be along Route 1 here, Route 1 here. At this location, well, you can't really drive across Long Lake there, and there's some roads that go through here, but they're not as efficient as Route 1. So Fort Kent is going to have a major advantage. Madawaska is going to have a major advantage. The St. Croix Lake here, Eagle Lake, they're all going to have to drive up here and around. So that's a little difference, but not a huge difference. But Van Buren is going to have more of a circuitous route here. And that's where infrastructure planning gets serious, and you have to have experts who know all these things, because the GIS can give you, yes, this is the geographical center of this population. A much more advanced GIS analysis could actually take that road distance for each one of these. But at a certain point, you have to call in the experts who know the region and say, well, this looks great, but these people, it looks like it's good for them, but there's really some insurmountable challenge. Maybe this road is closed sometimes. Of course, it's Route 1, it's not. But if you lived in the West, that kind of thing can happen, especially when you have a mountain pass involved. And that gets to the role of GIS. GIS is a decision support tool. It is not a final answer. It's something that informs the discussion of what to do in the real world. So here we've taken data from the census, we've visualized it as dot density, we've found the mean and median center of that population, and now you're ready to go into a planning committee meeting saying, these are the data, here's what the statistical analysis has given us, now let's discuss.